Hi guys, it's Mrs. Anglade. This video is going to cover lesson 8.3 and it's going to be the first part of it. So what we're going to talk about in 8.3 is all about the distributive property. So if we go ahead and take a look at what the first part of problem 1 says, it says installing carpet. The Lewis family just bought a new house. They will install new carpet in 2 adjacent rooms before they move in. And the first question wants you to, how would you calculate the total areas of the room? So what I want you to do right now, and I want you to pause the video while you do this, is I want you to go ahead and find the area of how much carpet they would have to find for the family room and the office. So pause this while you do that. Okay, so I'm going to come back, and so now some of you probably wrote that I'm going to find the area of the family room plus the area of the office and add those two together. So you have 143 plus 77. That gives me 220 square feet. Okay, that would be finding the family room and the office separately and then adding them together. Some of you might have said, well, you know, I can find the area of this entire rectangle. And so how do I find that? Well, my width is 11, right? But what is the entire length of the 2 rooms together? I would take 13 and add 7 to it. So I would take 13 plus 7 is 20. And then I would multiply 11 times 20 to get 220 square feet. Okay, now let's take a look at Brian. Oops, sorry. Brian said, I calculated the area of each room, then I added the 2 areas together to get the area of both rooms. So that was the first way I explained to you, right? Here's the area of the living room, here's the area of the office, and so together make 143 plus 77 equals 220 square feet. So if you don't have that written down, write that down right now. Let's look at what Sarah said. I multiplied the width by the total length of both rooms to find the total area. So here's the width and here's the total length. And so they say calculate the area. So I'm going to take 11. Order of operation tells me to add that together times 20, and that's how I get 220 square feet. Okay? It says, what do you notice about your results using each expression? What does that tell you about the 2 expressions Brian and Sarah wrote? I want you to pause the video, and I want you to take the time right now, and for number 4, write down what you saw about Brian and Sarah's expressions. Okay, so now we're back. So hopefully what you said about Brian and Sarah is you said, well, gosh, their expressions were both the same, right? But they just wrote the expression differently, but they still got the same answer. So those expressions are equal to each other. We call this a specific property. That property is called the distributive property of multiplication over addition. Okay, now that's a really fancy way to say that anytime I'm taking a number, let's say A, times a quantity, B plus C, that's the same as taking A times every one of those terms that's inside that quantity. So I'm going to take A times B, then I'm going to take A times C. If I had a D term in here, I could take A times D. If I had an E term. So where did we see that in the areas? 11 could be my A, 13 could be my B, and 7 could be my C. So what did that become? This 11 was multiplied by 13. And that 11 was also being multiplied by 7. This was Sarah's, and this was Brian's, right? That is the distributive property. Now, folks, we've been using that ever since you learned how to multiply 2-digit times a single digit in 4th grade. If you remember, like if you took 5 times 23, instead of taking 5 times 23, didn't you break 23 apart into 20 plus 3? And then didn't you take 5 groups of 20 and 5 groups of 3? Folks, that's the distributive property. You've been using that since 4th grade. We talked about this last week when we used our base 10 blocks, right? We took 5 groups of the 10s and 5 groups of the 1s, and we added that together. So this is 100 plus 15 to get that 115. That's partial products. We've been using this property, we just haven't given it a name. Not only can we do it over addition, but we can also use that property, the distributive property of multiplication over subtraction, which says if I have a number A times the quantity that I take B minus C, I can say that that is the same as A times B minus A times C. Now we saw that in our warm-up from yesterday. If you remember, it said 3 times the quantity, 8 minus 4. Now, I think all of us would use order of operations to say that that's 3 times 4, right? But here's what I want you to think about. Could I have also said that this could have been 3 groups of 8? I want to distribute this 3 groups of 8, and from that, could I have subtracted 3 groups of 4? I want you to think about that. That would be 24 minus 12. Would that still give me this 12 over here? Is that true? And that is a true statement, right? Okay, so that's the distributive property over addition and subtraction of multiplication. So that's what we're going to be focusing on today. So let's go ahead and take a look what they want us to do today. Okay, they want us to use the expression x plus 1, and they want us to figure out what 5 groups of x plus 1 would be equal to. This expression has 2 factors, 5 and the quantity x plus 1. Let's read what this guy says over here. When you're speaking about an algebraic expression, use the words the quantity. For example, if you have this quantity x plus 3, we would read that as the quantity x plus 3. So we have 2 factors. We have a factor of 5 and we have a factor of x plus 1. So let's go to our algebra tiles and let's see what that looks like as algebra tiles. So I want you to do this along with me. So get out your algebra tiles, and one of our factors is going to be x plus 1, and our other factor is going to be our constant of 5, right? Our constant of 5. So we're going to go ahead and get out this 5 yellows. Now remember what this means. Remember our base 10 blocks from last week when we did our product mats, okay? Remember, we let this represent, instead of this being an x plus 1, this was like a 10 and a 1, right? This would have been like an 11. So it's the same thing, right? This means that I'm going to repeat this group of x plus 1. I'm going to repeat it. How many times do you think? Hopefully you're saying I'm going to repeat it 5 times, right? 5 times. So let's see. What am I going to get whenever I repeat this 5 times? Let's see. That's 3 sets of x plus 1. Do you see that I'm filling in this area? Just like we did last week. Remember, we filled in our area to fill up that rectangle. And so I have filled up my rectangle now. Now this represents 5 groups of x plus 1. So let's add all of my like terms together, right? I have how many x's? Hopefully you said 5 x's. And how many 1s? How many of my constant? I have 5. So what is 5 groups of x plus 1? It's 5x plus 5. Okay, let's go ahead and take a look. And that's what they're showing down here, isn't it? Okay, let's go ahead and take a look at 1a. They want us to create this expression on our product mat, and then we're going to come back and we're going to sketch a model of that on paper like we did our sketches yesterday. So let's take a look at what this looks like with our algebra tiles. Let's take a look. It's 3 groups of x plus 2. So let's take a look at what that would look like. Let's get our x plus 2 up here first. And then I believe it said we wanted 3 groups of it, right? So that's going to become my other factor. And so this represents 3 groups of x plus 2. So what am I repeating? I'm repeating x plus 2. How many times? 3 times. So do that with me. So this is x plus 2. Another x plus 2. Make sure you don't have it on the red side. Remember, red means negative. We don't want negative yet. And so all together, let's see, 3 groups of x plus 2. What is that area going to be? What are my terms that I can combine together? So it looks like I can combine my 3x and I can combine my my 6 constants together to get 3x plus 6, right? All right, what's that going to look like as a sketch? Let's take a look at what that looks like. So I want 3 groups of x plus 2. Remember, my x plus 2 can look like this, and my 3 groups can look like this. And so we just repeated that x plus 2 3 times, right? So what does the distributive property say? Because that's what it's asking me to do using the distributive property. So this means we did 3 groups of x, right? That's that 3 groups of x right here. But we also did 3 groups of 2. We did 3 groups of 2. Here's 1, 2, 3 groups, right? So what did we say it equaled? 3x plus 6. What I want you to do right now is I want you to try part B right now by yourself. Now remember what 2x plus 1 looks like. 2x plus 1 is going to look like this, right? Use your algebra tiles if you need to, or you can just sketch it if you want. And then 4 is going to look like this. What I'm going to do is I'm going to pause this video and I'm going to come back and I'm going to show you the answer. Don't go on until you have your answer. So hit pause on the video before you look to see what my answer is, okay? So hit pause. Okay, so hopefully you drew this sketch. And remember what the distributive property says. I have 4 groups of 2x, right? That's how many times I repeated that 2x. And then I repeated 4 groups of 1. So what do you think this is equal to? It's equal to 8x plus 4. 8x plus 4. Okay, so what I want you to do is I want you to do part C. I'm going to pause it and I'm going to come back and I'm going to just give you the answer of what it should be. Okay. All right, so hopefully this is what you have. You have 2 groups of x plus 3 repeated that 2 times. So what did you do? You repeated 2 groups of x plus 2 groups of 3 to get 2x plus 6. Okay, we're going to skip part D, but what this was showing you is instead of doing it horizontally, we can do it vertically too. We could do 3x plus 1 and repeat that twice. They're just showing you that the commutative property does allow me to do the 3x plus 1 vertically up and down instead of horizontally. So what I want you to do right now, I'm going to do part A with you. We're going to skip part B. So I'm going to do A and C with you, and then I want you to do D, E, and F, and then I want you to see if your answers match mine, okay? So part A. Part A says I want 2 groups of x plus 4. So think about what that would look like with your algebra tiles. Do you agree that I would have 2 groups of x, and then I would have 2 groups of 4? So what do you think this is going to be equal to? 2x plus 8, right? Now look at part C. Part C is a little bit tricky. Take a look. Do you see that there's 2 sets of distributive properties here? I have 2 groups of x plus 5, and I have 4 groups of x plus 7. This would be like 2 different multiplication problems with my product mat, right? This would be 2 groups of x plus, what's 2 groups of 5? 10, okay? This one is now going to be 4 groups of x, which is 4x. Plus, 4 groups of 7. 4 groups of 7 is 28, right? So now what are we going to do? Is this in simplest form? No. Can't we combine the 2x and 4x together? 6x. And can't we combine the 10 and 28 together to be 38? So that is our simplest form answer. I want you to do D and E right now, and I want you to pause the video, and when you come back, I want you to check your answers against mine. Okay, so now we're back. So what you should have gotten for parts D and E is you should have gotten 11x minus 14 and 2x plus 2y plus 20 for that one. Okay, so that is the end of this part for lesson 8.3. So what I want you to do is I want you to do the assignment that you picked up yesterday of 8.3. I want you to do that entire paper with the exception of you are not going to be able to do D and F. Parts D and F I want you to wait on because you will do that in the second part of lesson 8.3. So D and F on that paper, wait, and you will do that in the next part of the lesson. Okay, so that's where I want you to finish the class with. Hope you had a great day. Thanks. Bye.